Hello dear students, let's see how to construct PDA from one more GNF. Now observe all the productions given in this grammar are again in gray batch normal form and we are asked to construct a PDA from this. Now you know all the observations, there will be only one state in our PDA, correct? And the terminal symbols or input symbols are A, B, C that can be seen from the grammar. And the stack symbols are non-terminals S, A, B, yes, and the Z0, the initial stack symbol will be S, which is the start symbol. All these things we had seen in the previous video. Now what about delta? Delta, the transition function. To find delta, let's take the first production S derives AAB. We'll define delta as in Q0 state, there is only one state, remember Q0. In Q0 state, when the machine reads A and top is S, then this S is simply replaced by AB. Just check, this AB has been written here, correct? And what about the second transition? Let's take the second production, A derives BB. Then in Q0 state, when machine is reading B and top is A, then machine stays in Q0 and this B will be written over here. That means A, which is on the top of the stack, will be replaced by B. A will be replaced by B, correct? Let's take the third production, A derives B. How will you define the transition? Q0 is reading B and top is A, and now machine stays in Q0, but epsilon will be the letter which will be replacing A because there is nothing written after B, so this becomes epsilon. And the fourth transition is, or a production is, B derives C, then we will get Q0 C B or results in Q0 epsilon. That's it, and the PDA is constructed. So I'll just write, give me some time, I'll write all the transitions. The first transition is Q0 AS, Q0 AB, Q0 AS, Q0 AB. This is the first delta that we have got. The second one is Q0 BA, Q0 B, Q0 BA, Q0 B, correct, I think, yeah. And the third we got was Q0 BA results in Q0 epsilon. This is interesting. Q0 BA results in Q0 epsilon. Now watch this. Watch this particularly. This delta and this delta. Isn't the configuration same? That means if the machine reads B and the top is A, if the machine reads B and top is A, if the machine reads B and top is A, check thoroughly, same configuration, then it may result in replacing A with B, or it may result in removing A, that is replacing it with epsilon. We typically write this in our working, although for GATE this working is not needed, or how you present the things is not needed, but in general we write this as follows, that when Q0 reads B and top is A, then it may result in one of these results. This is clearly multiple actions for the same configuration. This is NPDA. And one more transition that we got, the fourth one, that was Q0 CB results in Q0 epsilon. Q0 CB results in Q0 epsilon. Typically, all the entries of an NPDA are shown as a set. Remember, we did the same convention in NFA also. Yes, the resultant configuration was shown as a set and the set might contain multiple results. Now, let's see the working of this. We will not draw diagram anyway. We won't take a time to draw the diagram, but diagram is really unnecessary because there is only one state. Just check, how will you write this in the form of first transition? Q0 reading A, top is S, results in AB. How will you write this second one? Q0 reads B, top is A, replaces A with B, but Q0 reads B, top is A. Check the repeated configuration. Check this. Results in epsilon, and one more. Q0 reads C, top is B, results in epsilon. So the diagram is really not necessary, isn't it? There is only one state, no final state. But then what we can do is we can show working for one particular string on this, and you can find out that the smallest string generated from this grammar can be ABC. Let's try the input ABC. So Q0 has been given ABC and top is S. Yes, initially the stack is going to contain the start symbol. Now Q0 is reading A, top is S. Just check. Q0 is reading A and top is S. We are using the first transition. Then we will just replace this S with AB. So what really happens is that S is replaced with AB and the input pending is BC. I hope you are understanding. So this S in the stack, just observe, this S in the stack is now loaded with AB. Now starts the fun part. Q0 is reading B from the input and top is A. Tell me what you should do. Wait a minute, just check this second configuration that or second transition that we have written. Q0 is reading B and top is A. Then machine might do this or this. Then we will show non-determinism by showing two branches. Machine can either replace this A, observe, replace this A with B. So what we have is Q0 C remaining because B is consumed, and this A is replaced with B, and one more B is still pending on the stack. Or machine can use this configuration, just check it, this result. So it means it will remove A. That means Q0 C is remaining and B remains because A has been removed by epsilon. Watch out, we have two branches now, and what our NPDA will do, it will actually expand both the branches. It will see whether this branch leads to the result or this branch leads to the result. Whichever is early, PDA will stop. So let's see this configuration. Q0 is reading C, top is B. Yes, Q0 is reading C, top is B. Check this third configuration. It has only one action, remove B. So what will happen? Now we will not show branch over here because it results only in one action. Q0, epsilon remaining, C is consumed, and this B, the top B is popped. So only one B remains. This is next to useless result because, just check, we can't proceed anymore because the input is finished. Input is finished, but stack is not empty. Stack is not empty. Sorry for my poor handwriting in this video, but both should be satisfied. Only then you will say, okay, we have reached our final configuration. But although the input is over, but the stack still has B. That means this branch is not going to be expanded anymore because this configuration cannot be expanded. So let's see this. Another possibility. Q0 is reading C and top is B. Just check. Q0 is reading C and top is B. Then it says stay in Q0. Nothing remains in the input. C is consumed and pop B also. There is only one result. So that's why we have not shown branch over here. Then input over and stack empty. Both true. That means this is the branch which has given us acceptance of the string ABC. ABC, this string which we were working on, is accepted. Let's very quickly see one more example string. You will agree that this grammar also generates a string A, B, C, C. A, B, C, C. Okay. Let's see how A, B, C, C will be accepted. You can obviously start working on this particular problem where the input string taken is A, B, C, C. Okay, fine then. Here we go. This is the stack. Initially the stack contains only S. So A, B, C, C, and the stack is having S. Now you note in our configuration, the first written is Q0 AS results in Q0 AB. So there is only one action, BCC remains and S gets replaced with AB. Now Q0, so this S by the way gets replaced with AB. Now Q0 reading B top is A. Oh my god, this results in two actions. One is replace A with B. So it will be Q0 CC and A is replaced with B. And the second action is that pop A from the top of the stack. So we'll say CC is remaining and only B remains because A has been popped. Now we have to expand both, rather PDA will do it. So what happens when Q0CB is encountered? Just check. Q0CB means pop that B from the top of the stack. Just check this. Pop B from the top of the stack. So we will have only one action. We will not show any branch here. Only C remains and B remains because the B has been popped. Now Q0CB, check it. Q0CB again. The same transition we are talking about. That means Q0 epsilon epsilon because B will be popped. That's it. That's it. This is acceptance. Although we don't have final state in this PDA. Yes, this is PDA without final state, but this is PDA by empty store. The input is over and stack is empty. That means ABCC is the valid string. No need to magnify this. No need to expand. There is no sense in expanding. Or let's continue. Maybe let's continue. What if? What if we expand this? I repeat, there is no sense in expanding this because we have got the acceptance. But Q0CB results in, yes, the same third transition I am talking about. This will result in Q0C epsilon. Now you watch, input not over, but stack empty, stack empty. Both conditions should satisfy. Remember, input should be finished and at that time stack should be empty. But input is not finished, then this branch is not acceptable. This branch is acceptance of the string ABCC. I hope you have understood working of GNF to PDA. If GNF is given, how do you construct PDA? You have understood it, and you have also understood non-determinism, how NPDA is generated if such a GNF is given. Thank you very much.